All right, lesson 12.5. What we want to talk about today are the concepts of congruence and similarity. Congruence and similarity. They are similar but different. Congruence and similarity. So we're going to deal with congruence first. So the first thought is, what are congruent polygons? C-O-N-G-R-U-E-N-T. What are congruent polygons? Now you guys don't have the picture of the blue polygon and the red polygon. That's fine because I want you to just look and watch. Now first off, what kind of polygons are these? Pentagons. They're five-sided. Are they regular pentagons? No, they are not. Regular are all angles are congruent, all sides are congruent. They are not regular pentagons. All right, well here's the relationship for congruent polygons. Again, don't write, just watch. See this bottom left angle on the red one? It's congruent to the bottom left angle on the blue one. The left angle of the red one is congruent to the left angle of the blue one. The top angle of the red is congruent to the top angle of the blue. The angle on the right of the red is congruent to the angle on the right on the blue. And the bottom angle in the red, 2, 3, 4, 5, is congruent, 1, 2, 3, 4, 5, to the bottom angle in blue there. And so to say that geometry-wise, we say all corresponding angles are congruent. The corresponding ones, the ones that match. And we'll talk about corresponding in just a couple moments. But it is important to make sure we're dealing with the correct angle. And because the polygons are congruent, all corresponding sides are also congruent. Not all sides are congruent. That would be a regular pentagon. All corresponding sides are congruent. So the left side on the left, if that's a 1 on the red, then on the blue, that's a 1. They're congruent. And if I move up, that one would be congruent to that one. Get the idea? Because they correspond. This one here to this one here. This one here, 1, 2, 3, 4. 1, 2, 3, 4 to that one, and 5 Roman numeral. Ah, look at that. Got away with a different marking. Yeah. All right. Corresponding sides are congruent. That's what makes them congruent polygons. So if you are told that you have congruent polygons, you automatically know that the corresponding angles are congruent and the corresponding sides are congruent. So in your notes there, you guys have this illustration. And we are told that triangle ABC is congruent to triangle ZYX. We're told that. Because we're told that, I know this. So take your red. I know that angle A is congruent to which angle? Don't say it yet. Angle A is congruent to which angle? On 3, give me your answer. 1, 2, 3. Z. It is angle Z. Angle A is congruent to angle Z. Angle B is congruent to angle, hold on. All right, on 3, say it. 1, 2, 3. Y, because I asked. And thirdly, angle C, therefore, then is congruent to angle X. All the corresponding angles are congruent. Now we can do the same thing with sides. Now notice the sides are line segments. So let's go line segment AB. So that's the letter AB with the line segment symbol over top. And that's going to be congruent Now you got to be careful here. Geometry is a technical discipline. It's kind of like being a lawyer. Your client may be guilty, but if the prosecutor doesn't technically execute the law, the guy may get off. Well, geometry is like that. You got to be technical. So if I say line segment AB, somebody raise your hand. What do I say for line segment on the other one? Give it a shot. Raf? ZY, how many agree with Raf? ZY, and that would be the correct designation. It's got to be ZY, not YZ. Line segment AB is congruent to line segment ZY. Secondly, line segment BC is congruent to line segment AD. No, all right, line segment BC is congruent to what line segment? Christina? It is YX. And then thirdly, line segment CA is congruent to line segment, who can give me that one? Luke? XZ. It is XZ, correct. So now I want you guys to just watch for a moment, and I don't know if you caught this. If we didn't have the picture of the two triangles, if we didn't have it, so for example, suppose we didn't have this picture at all. Come on. Come on. So if we didn't have this picture, we could still write all of the stuff we just wrote without the picture. Could you? Could you? Well, that's, you need to. And it all comes from right here. So again, watch. Angle A, we said goes with what angle? Z. We said angle B goes with what angle? Y. We said angle C goes with what angle? See how you could write that without any picture? Because you were told triangle ABC is congruent to triangle ZYX. And not only that, without a picture, look at the sides. What side did we say side AB was congruent to? ZY. See that? And didn't we say BC was congruent to YX? And the other ones, we went C to A, therefore we go X to Z. See how you could do it right off of the fact that they are congruent. So two things. You should be able to take somebody telling you two things are congruent. You should be able to list all the congruent angles and all the congruent sides and list them properly from the lettering. Or somebody could give you a picture. So we could give you the picture and ask you instead to say triangle ABC is congruent to what triangle, and you should know to list in the proper order and say triangle ZYX. You should be able to do it both ways. Okay? It all comes from the way things are ordered, and this is what we mean by corresponding sides, corresponding angles. The ones that go together. All right? So the lettering does that for us. The markings do it as well. Now, we didn't bother to mark the angles. Let's go through and do that. Notice that angle A, I'll put a 1 arc mark, is congruent to angle Z. I'll put a 1 arc mark. And angle B, I'll put a 2 arc mark, is congruent to angle Y. I'll put a 2 arc mark. And angle C, I'll put a 3 arc mark, is congruent to angle X with the 3 arc mark. I'm a poet. Do you know it? All right. But again, we don't need all of that if we're told they are congruent. So we should be able to go both ways. Okay, so real simple questions here. Uh-oh, no picture. If triangle PQR is congruent to triangle TSR, First question, don't say anything out loud. What angle is congruent to angle Q? And hopefully you all say angle S, right? Because Q is in the middle and S is in the middle. Q is in the middle and S is in the middle. The second question is, what side, and don't say anything out loud, what side is congruent to line segment ST? So let me give you a second. What side is congruent to line segment ST? The order matters, so be careful. All right, on three. 1, 2, 3. Q and then the P, right? It was the middle one to the first, right? We went middle to first, so we got to go middle to first, right? Got to follow the same order to be technically correct, okay? Questions on that? Now look, we could also do something like this, and let me just take a quick moment to do this. And for time's sake, don't write it in your notes. So I had a triangle like this, and let me make a similar one, or a congruent one. Okay, there is a congruent one. Right, a copy is congruent. Oh, I spun it. Ooh. And let's say this was JKL, just watch. All right, JKL. And this was PQR. All right, JKL, PQR. And let's suppose we had markings. A 1 there, a 1 there, a 2 there. My brain, get it right. Boy, they don't look the same, do they? They look better there than they do on my screen. Okay. So 2 there, and 3 there, and 3 there. So watch. If I say triangle JKL, what must the 3 letters be of the second? Don't say anything out loud. You got to get it in the right order. JKL. So I named triangle JKL. I told you the 2 triangles are congruent. What order must the 3 letters be in for the second congruent triangle? Go for it, Luke.
QRP.
Does anybody agree with Luke? QRP. And you are correct. You notice how we had to go in order. And you can look at the arc marks to figure it. This is the way I do it. J to K is the 1, K to L is the 2, and L to J is the 3. So do the same thing. Q to R is the 1, R to P is the 2, and P to Q is the 3. So keep it in that order. That's the way I look at it. You should be able to do that. Okay, well that's congruent. Not only do we have congruence, but we have similar. Come on. Being rebellious. So number 2, similar polygons. Thank you, Windows. Appreciate your ministry. Similar, S-I-M-I-L-A-R. Similar polygons. A similar polygon, listen now. A similar polygon is an enlargement or reduction of the original. An enlargement or reduction of the original. Here, let's go with pentagon's the easiest one to see, so I'm just going to stick with a pentagon here. Okay, so I got a pentagon. Let's make it a little bit bigger for you. Okay, so there's a pentagon, right? If I copy it, it's probably up here now, right? Ugh. I think I have to paste. Edit, paste. Okay. Come on. Get over there. Right now, those are congruent. Those are congruent. But if I take it by the corner and enlarge it, those are similar. Those are similar polygons. If I take the original and reduce it, those are similar polygons. So notice what happens with the angles and notice what happens with the sides. And I'll enlarge this one. So what can you tell me about the angles? What happens to the angles? Kristen?
They stay the same.
So what's the technical word for that?
The
Corresponding angles are congruent. Congruent. Let me show you with a triangle here, because triangles are easy to see the different size of the angles. There's a triangle, right? I'm going to copy it. All right, right now that's congruent triangle, right? But if I enlarge it, I have similar triangles. Notice the corresponding angles are congruent. This angle is congruent to that angle. This angle is congruent to this angle. And this angle is congruent to this angle. Could have used the right angle symbol there. You see that? The corresponding ones are congruent. All right? Because, again, similar is an enlargement or a reduction. All right. So the angles are congruent. What about the sides? Are the sides congruent? No. Are you telling me that from there to there is the same distance as from there to there? No. So the sides are not congruent. So the sides are something that begins with the word P. Christina. Not perpendicular. Perpendicular are lines that form right angles. Allison. Not parallel. Although it seems like you could get away with parallel, but Allison, we could spin the other one that's similar, right? So if we spin it, then that'll mess up parallel. But as it was sitting originally, you would think parallel would work. So not parallel. I'll give you the second letter. First one is a P, the second one is an R. All right, shout it out if you think you know it.
property of triangles. Proportions.
Proportional. Proportional. Oh, I keep grabbing the wrong thing. Angles are congruent. Sides are proportional. Angles are congruent. Sides are proportional. Let me just erase here. Be easier. Sides are congruent. I'm sorry, angles are congruent. Sides are proportional. Okay. So I'll show you what that means in a moment and show you how that works with numbers in a moment. Let's just list off the things that work here. So looking at the notation, we don't need to see the shapes, right? We know angle J is congruent to what angle? Correct. We know angle K is congruent to what angle? Because I need to know. And we know angle L is congruent to what angle? Z. Now, how do you do proportional? And I'll show you. Proportional are numbers, so we don't use the line segment symbol over top. Whenever you give the two endpoints, you mean the distance if there's no symbol. So, for example, if I go JK, I mean how long is line segment JK? How long is the line segment? To make a proportion, if you guys remember, we've done proportions, they're fractions, right? So if JK goes on the top, what goes on the bottom? Say it if you think you know it. It is xy. JK is proportional to xy. Not congruent to xy, proportional. The next one, I'll go KL. The distance from K to L is proportional to the distance of what? YZ. And the thing about this, because there's three sides, we get three fractions. And the last fraction is LJ over ZX. Correct. And guess what? You guys can't do this. Actually, I'm not even going to be able to do it very well with my lines. You could switch tops and bottoms as long as every top goes on the bottom and every bottom goes on the top. Okay? I know my lines didn't end up in the right spot. Okay? So I'll show you how we're going to use them. All right? So in C, we're told this. We are told triangle ABC is similar. By the way, what's the name of that symbol? We talked about this, I believe, before. It's a key on your computer. I heard this on Jeopardy or something the other day. Anybody know the name of that? Begins with a T. It's a tilde, T-I-L-D-A. All right, the tilde is the similar symbol, a tilde. Right? Looks different than congruent, right? Congruent has the equal sign under the tilde. Just the tilde means similar. Equal sign under the tilde means congruent. Okay, we know that these two triangles are similar. And by the way, here's a principle, property. If two angles only are congruent to two angles of another triangle, guess what? The triangles are guaranteed to be similar. If just two angles of one triangle are congruent to two angles of another triangle, guaranteed the triangles are similar. All right, so let's go ahead and work through this. We want to find the distance from L to M. I'm going to take my red. I'm going to draw it in red. This is the distance we are looking for, right? L to M. And we're going to use a proportion to figure out the answer. So take your blue. I'm going to make a fraction bar, equal sign, and fraction bar. Now you might say, Mr. Scarfi, I thought we just said there were three fractions. Well, you only use two at a time. You only need two of the relationships, not all three. Now, I've already taught you this principle. The easiest way to solve a proportion is to put what you're looking for where? Top on what side, left or right? Easiest way is top left. What are we looking for? LM. So I'm going to put LM on the top left. Now, I could either, from the way it's listed, know what corresponding side goes with it, or I could go off of the markings of the angles. So, what side of the other triangle goes with LM? Chloe? It is BC. I'm going to do this one in green. We'll put the numbers in a minute. I just want you to see clearly the proportion. Now, sometimes you don't know all the rest of the numbers, and that might choose you. Now you got to go back to your triangle that you started with, LM, the one you're looking for, and pick another side. Now, if you know both sides of this one and that one, it doesn't matter. And this one doesn't matter. So let's go with MK. So I'm in red. This is the big triangle. MK. If I use MK off of the big one, what must I use off of the little one? Say it if you know it. CA. Okay. There you go. Now let's put the numbers in. I'm going to use the variable X for LM. Is that okay with you guys? Use an X. It's a little easier than two letters. So what goes in for BC? Right? What goes in for BC? 6. What goes in for MK? 21. And what goes in for CA? 14. Okay. you remember how to solve this proportion very easily? Somebody raise your hand and tell me how to solve this. How do you solve this? Colby? That you're not ready to reduce before multiplying because of the equation. So it's an equation. Aaron? Yeah, we want to move this 6, right? So we'll multiply the left by 6 over 1. We'll multiply the right by 6 over 1. It's the easiest way to solve this. And this is why I always put what I'm looking for in the top left, and you always do this to solve. It's always this easy to solve the proportion if you put what you're looking for in the top left. Do you have to put it in the top left? No. It's just the easiest. So what happens on the left? The 6's go away. Didn't we isolate the variable? And what's left on the right is now the time, Colby, to R-bum. Let's reduce it out. So again, be careful. A 14 is a 2 times 7. A 21 is a 3 times 7. And a 6 is a 2 times 3. There's a lot of reducing, right? The 7's reduce and the 2's reduce. And you could have just done it on your calculator, but sometimes the answer will be a fraction. So we end up with 9. We end up with 9. So L to M is 9. Watch this. Doesn't 9 divided by 6 equal 21 divided by 14? And doesn't that equal 15 divided by 10? It does. Doesn't 6 divided by 9 equal 14 divided by 21? It does. And doesn't it equal 10 divided by 15? It does. They're all 2/3. Proportional. Proportional. Now, I could make a bigger triangle. Don't you guys do this for time's sake, but watch. I could go a little bigger. That's similar. And this one is 10. If I double it, that one's 20. Now this one's twice as big. So this one being 6, this one must be 12. And this one being 14, this one must be 28 if they were similar triangles. Now those two, this one's double that one, right? Proportional. All the sides stay in the same proportion. That's the idea and that's the concept. Okay, let's do another example here. All right, D here is a classic example where they don't tell you the triangles are similar. So watch this. Thank you, Windows. Appreciate your ministry. This angle right here is congruent to that angle right there. How do I know that? How do I know those angles are congruent? Amber? Vertical angles. Awesome. And guess what? This side is parallel to this side. And because those sides are parallel, guess what else I know? I know this angle is congruent to that angle. You know why? How do I know that? What kind of angles are they? Alternate interior angles. Awesome, right? You kept the lines going, right? Don't you see the alternate interior angles? They are. All right, anyhow, the two triangles are similar. All right, what do they want us to find? PR. So let's label PR as an X, okay? And why don't you try to set up your proportion while I set up mine? Be careful. Let the markings of the angles help you to correspond. It's a little tricky. Tell you what, let's stay together here for time's sake. If I went PR on the top, that's the little triangle, right? What side goes on the bottom? What goes on the bottom? It is the 46. See how the P to R is the 1 mark to the 2 mark? So you got to go to the side that's the 1 mark to the 2 mark. It is the 46. So the 46 of the other goes on the bottom. And let's use the ends. They're the easier ones, right? If I use the 6 of the little, I definitely know to use the 18 of the big. All right, and again, how do you solve this? Multiply both sides by 46 over 1, right? To move the 46. And again, you would R-bum the 6 and the 18 easily reduce, right? And you actually end up with a fraction on this one, 46 thirds. That would be the value. That's kind of odd, but that's okay. That's not a problem. We got a fractional answer. Technically, it would be what? About 15 point something, right? 15.3, I believe. 15, because 3 times 15 is 45. So 15.33333, okay? All right, let me show you one more before the bell rings. If I can get it to go up there for me. Come on, go higher. Go higher. All right. Here's another situation. Look, this one's a little trickier. Do you see they both have a right angle? The little and the big. Yes? Watch this. Don't they both share this front angle? They both have the same front angle. So if they both have the same front angle, doesn't the front angles have to be congruent to each other? Has to be. So guess what? These are similar triangles. They have to be. So in this one, if we're looking for x to z, and I'm going to use an n now, we're looking for that value. Do you agree? X to z. So if n's on the top, what number goes on the bottom? N's on the top, what number goes on the bottom? Say it if you know it. 26, right? The one that corresponds to the big triangle, yes? Now, I'm on purpose going to use the 22 because sometimes they don't give you every number. Actually, either one is tricky, so it doesn't matter. But if I use the 22, most people get the bottom number wrong. Anybody have any idea what the bottom number is? Say it if you think you know it.
34.
And that's the wrong answer. Stop talking now because of time's sake. When you say 34, you're going from there to there. Is that shape a triangle? Here's the triangle right here. Let me use purple. It'll stand out better. Here's the big triangle, right? Don't we need this side of the big triangle? How much is that side? 56. All right, be careful of that. That's a mistake a lot of people make. And we won't finish it for time's sake, but we know how to finish the proportion. Do you see how that's a 56? All right, do you guys have the homework written on the bottom of your page? All right, very good. We're getting close to the end, so hang in there, and we'll pick up here on Monday.